This lesson is on the midpoint formula. Now, in order to understand what the formula is, it's probably best to know what a midpoint itself is. But in order to know what a midpoint is, we have to know what a line segment is. Luckily, neither of these things are too complicated, so it should take only a minute to go over them. First off, line segment. As the name implies, it's pretty much a line, but it's only one piece of a line. A real line goes on forever in both directions, but a line segment has two endpoints. It kind of stops on either end. Because they don't go on forever, every line segment has a spot that's right in the middle, the midpoint. Whether the line segment is long or short or horizontal or any other way, the midpoint is the point right in the middle. Knowing exactly where the midpoint is handy for a number of reasons, but it isn't always obvious how to find it. When the line segment is either perfectly horizontal or perfectly vertical, the only thing you need to know how to do is count and then divide by 2. But when the line segment is diagonal, like this, knowing exactly where the middle isn't quite so straightforward. So what do you do? Well, that's what the midpoint formula is made for. As long as we have the endpoints, we can simply substitute the values in, and the midpoint coordinates pop out. But formulas like this are easy to forget, so let's real quick take a look at where it comes from. That way, in case you forget, you can still figure it out the long way. All the formula really does is find the middle, or the average, of the x's, and then the middle, or average of the y's, separately. In our previous example, the line segment started at x equals 4 and ended up at x equals 10. You could just count your way to the middle, or find the average by adding them together and dividing by 2. Either way, we find that the midpoint must be at where x is 7. The y's, on the other hand, went from 1 to 5. That makes the y coordinate the number right in the middle, which is 3. And sure enough, there's our midpoint, 7, 3. Throwing some negative numbers into the mix can make it a little trickier, so let's try a few more for some quick practice. How about this? Find the midpoint between the 2 points, -5, 3, and -1, -3. We could use the formula by calling the first x, x1, the second one, x2. Do the same with the y's, and substitute the values in like so. The x's are pretty straightforward, but notice how the y's have canceled out and turned into a 0. Nothing wrong with that. 0 divided by anything is just 0. So that makes our midpoint -3, 0. Last example. Find the midpoint between 1, 6 and 2, -2. When we substitute into our formula, we notice that this example isn't going to give us as nice of an answer as the rest of them did. That's because we end up with an odd number when we add the x's together, and sure enough, halfway between 1 and 2 is 1.5. To quickly review what we've learned, the midpoint formula helps us find the point that is in the exact middle of any line segment. If we know the endpoints of the line segment, then the midpoint has the coordinates given by this formula, and all this really is the average, or the middle, of the x coordinates and the average of the y's as well.